Okay, today's problem is process string special operation 2. So we are given string S consisting of lowercase English letter and special character star has an modulo symbol. Okay, percentage or modulo symbol. So it is a continuation of part 1. So the same problem statement in the part 1. So let me read the problem statement as well. We are given an integer k. Build one new string result by processing is according to the following result. So what is the result? Star means we'll remove one character from the result. For an example, A star, let's say B A, then B A, then star. Okay, that means first I will include B, then A, then star I will get, so I will remove B. This is the meaning. Has means duplicate the current result and append to the selection. BA has, that means it is BA, BA and then BA. So first and modulo means reverse. So BA modulo means first I will do B, then I will add BA, then it will modulo means it will reverse the string BA. So this is the case. So later the English lowercase English, so sorry, if a letter is a lowercase English letter, then append it result. So that's why appending the result. So B, it is an English lowercase letter, so simply add into the string. Similar to the same problem statement with the problem statement number 1. So what is given here, it is duplicates return the kth character of the result. So let's say this is my, for this string the kth character will be, let's say it is 0 1 2 3. So kth character means, let's say k equals to 1, then I will return from here, I will return a. So let's say here k equals to 0, it will be 0 1. So in this case it will be also a. And what if the k is out of bound, the result return dot, let's say here, let's say k equals to 3 here, but here you can see the final output is nothing but b, so only one string is present. So but here k equals to 3, so that means k is out of bound, right? In that case return one uh, period or a dot symbol. Okay, so you can see, you can think of like previous attempt, like do appending into the character, whatever the step means like I will do according to the step, but you cannot do this because length is 10 to the power 5. It will be too much of length. So as I told you earlier, what is the maximum length of the string? So let's say length of string is n, and it could be what? N string could be a, then star, then again has, then dot 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 has. So it will be 0th index, this will be n minus index. So that means n minus 1 times has is present. So what will be the output for this? For A, it will append, then double it. For 0th index, I will simply add it. For the first index, for 0th index case, I will simply add it. For index 1, hash is present. So index 1, for this hash, it will be double. For index 2, again hash is present. For index 2, it will be again double. So index 3, again hash is present. Index 3, it will be again double. So it will be 8 because 4 and 4 plus 4 8. So how many you can, if you see that how it is growing up exponentials, you can see length of the string to the power 0 here, that means to the power 0 is 1, to the power 1, to the power 2, to the power 3. You can say it is going to the exponential case. So what is the maximum length it is possible you can generate? For if it is n minus hash could be present, in that case 2 to the power n minus 1 item is present. Okay, so here maximum item is 10 to the power 5 is length is present. So in this case, how what is the maximum length could possible? 2 to the power 10 to the power 5 minus 1. That is the maximum length possible. So it is literally a huge length, huge. So we cannot generate that string, cannot store in a single variable. And also see that you can see from here as well. Here it is mentioned like A consists of lowercase English character and special character is like asterisk, sharp, and hash and modulo symbol. That's fine. K could be 10 to the power 15. So here see length of the result after processing the S will not exceed 10 to the power 5. So it may go to 10 to the power 5. So it is a very huge string. So we can't store the string. Okay. So what is the reverse way we could do that? So is there like not reverse way, like what is the alternate way? How could we solve this problem? All to solve this problem in alternate way, we cannot track the character, so we cannot generate character or store it to the character. But what we could do, we can store the character, like length of the character. One string it is mentioned here. See here, if k is out of bound, okay, out of bound of the result, so I will simply return dot. So we could check the length of the character it may create. So how could we check the character of length? Okay, let's remove this all everything. Let's take an example. What could be the length? Delete. So if anything is present, let's say a b c, then sharp, then say d, then again hash, then percent modulo, then asterisk, then a, then modulo, then sharp. Let's say this is my string is there. Okay, can we find out the length of this? What is the output length? See, it is simple. If lowercase English character is coming, I will simply add into the length. So length will be initially 0. So first case is this one, a. I will simply include into the my result, so it will becomes 1. So again I will include in the next letter is also, next character is also English lowercase, so I will simply include into 2. So then I will come see, I will simply include a 3. Okay, now has or sharp it is coming. Okay, so for this one the length will be double. So currently it was ABC, it will become double, ABC plus ABC, so it will be doubled. So that means 3 will become 6. Okay, then D is nothing but one single English lowercase letter, so I will simply add into the append into the string, so it will become length will be the 7. So then again sharp, for sharp it will become double, 14. For modulo it will just reverse it, it will not update, it will not update the length, it will not have any contribution on the length, so it will not update. For 14 will becomes 14, no update. Then asterisk will reduce the thing. Let's say it is right now a b c d is added, then again like a b c whatever the thing is string, let's say whatever the string is surrounded, let's say it is this, let's say for an example it is this. So after asterisk will come, asterisk will reduce one length, right? So that's why 14 becomes 13. Then again one lowercase letter, it will again become 14. Then reverse like modulo means reverse doesn't contribute, so it will fine. And again sharp will double the thing, so it will becomes 28. So we can finally we can say last item is nothing but last item is 28. So last item in the sense the result, length of the result is 28. So we can simply calculate the length, and we can check whether k is out of bound or not. If k is what k, remember I have to return the kth character, that means here k is the index position. So what is the index? Let's say a b c d e f g e f e something. Okay, what is the index? 0 1 2 3 4 5 6. So in the question they can ask for sixth character, right? So what will be the length of the string? Length of the string can be like k could be the last character. So last character in it is 6. So what could be the length of the 6? Nothing but 6 plus 1. So this one is 7. Correct. So k could be the last character. So if length could be 7, so k plus 1 will be the length. This should be, it should not never exceed this. If it is exceed the length, so length is, for in this case for this string length is 7, length is 7, so k could be anywhere between 0 to 6. Okay, but k could be anything 0 to 6. So k plus 1, so that k plus 1 could be the length, so k plus 1 cannot exceed length. Okay, if that is the case, k plus 1 exceeding the length, that means it is out of index. Okay, hope you get it. So why k plus 1 cannot exceed the same? Say why I am saying like k could be 6 as well, right? 6 and plus 1, that is nothing but my length. So it cannot be exceed the length. So if you don't understand this thing, you can write k cannot exceed my length minus 1. So k could be, you can write this condition as well, because you can say length is 7, so so my valid k values would be 0 to 6. So if k could be cannot be exceed l minus 1. So L minus 1 is nothing but 6. So if it is 7, k becomes 7, there's an invalid case, then we will return on period. So that is the case. Hope you understand. So fast we calculate the rent. If fast only we can figure it out, like whether it is out of bound or not. If it is out of bound, we will simply return like it is returned at period. So it will not create any problem. Hope you understand. So this is the case. So if we write that code first, to write that code, if I have to calculate the length of that k, I can write that thing. Let's do this one by one. Length could be, length is initially 0, so I have to iterate each and every case. So for each character in this string I will iterate. Okay, if my character is equals to asterisk or star, what I'll do, I'll simply reduce it. But think of it, it could be string, my string could be this thing. If this is the string, so my result is nothing, like result stores nothing. So I cannot simply just reduce by minus 1. We have to do such a way so to check if it is valid. If this is a string, if this string is given, if this string is given, my output will be one ABC only, correct? Because star initially it was empty string, right? Then I am applying star on it, so nothing is there what to delete, so it will become empty string only. So then ABC will be appended. So that's why if in this case, I have to check another condition. If my length is greater than 0, if the length is greater than 0, then only I will reduce the length by 1. Length minus 1, length minus equals to 1, or length minus you can say minus equals to 1. Okay, this is the case. Okay, what are the cases? If my character is equals to my s, then what will happen? I will simply do length, I multiply the length. So in this case, we will simply length will be doubled. Multiply equals to 2. So else if, don't write if, because see, if first statement is true, why to check second statement? If we simply write if, it will only check like each and every statement will be checked. So that's why else if. So what if else if is if character equals to has. Okay, this is the one case. Else if, what is the other case? Else if character equals to modulo, right? If it is modulo, we will not do anything, we will simply write continue. Okay, so after that last string is if not none of the above is true, that means it is an English lowercase letter, right? So if that is the case, we will simply do length will be increased, because see, it will be simply appended if it is an English lowercase letter. So that is done. At the end we can say, like, we'll check another if statement. If as I told you, if k is greater than l minus 1, okay, if that is the case, then we'll simply return that period. Simply if k is greater than that, then we'll simply return one string, that is nothing but one correctness. This one correct. Hope you are getting it, what to do. Okay, this is for the basic check, initial checks, right? The initial checks are done. Now this is the edge case, you can think of it. So this is done. Now what we, okay, now the main problem is we can't generate the characters, right? Because to generate the characters, it will take too much spaces, 10 to the power 5, too much spaces it will take. So we cannot generate the character. So what are the character could be? Character could be English lowercase letter and 3 special characters. So instead of generating, can we backtrack? Like, can we check when that kth letter appear first? we can see this thing, or we can ask of a question like where from this k letter is coming, which letter should say k letter will be nothing but what is the string given. Among the string there will be, among the string whatever going to happen in the result, only English letters. So kth letter obviously part of any of the character which is lower English characters that is present in my string. It will be obviously among all those characters, it will be one of them, correct? So let's see how we could do that. So if my string contains only lowercase letter x, y, z, a, b, c, this kind of thing, and if they ask for k, we can simply return it. We can return that s of k. Simply return that if it is k is not out of index, out of bound. But it is not only lowercase character, it is there present like hash present, star present, asterisk present, and modulo present. So let's check one by one, like what is the effect of this asterisk or hash or modulo. Let's check one by one. So let's start with our asterisk. Asterisk means what? Asterisk means deleting the case. Deleting the case. So if k equals to 0, if you apply this thing, this will be my final string. Okay. So let's go through this. A is appended, A is added, then it is removed. Asterisk means remove the last. So initially it was empty string, it becomes again empty string. Then B is added, so B is added. Then C is also added, so C is also added. Fine. Then asterisk. Asterisk means I will remove the C. It becomes B. Okay. Then what will happen? Then D. And after that E. So D will be appended, it becomes BD, and then E will be appended, then it becomes BDE. Then again asterisk. Asterisk means again remove the character E. So it becomes BD. Okay. So what I have to return? K equals to 0th index. 0th index, right? So 0th character. This is nothing but I can say final character is BD, 0th character is B. So that's why mark is as red. So this is my final character. So as we can't generate our result string, what we could do? We can say when this 0th character is fixed. Like why I'm saying 0th character is fixed, because see, as in the example it is a star, so 0th character is not fixed. One moment it will come when I notice 0th character will be fixed, correct? It could be any number of a star present in front of that, so that means how doesn't matter how many characters present, if it is character one by then character then asterisk, that means that will be deleted, so what I could do, from the left side I cannot calculate what will be the character, because it could be asterisk, it could be modulo, so that it will be reversed, that kind of thing we cannot calculate, correct, from the beginning. So we are going to do the backtrack. In our hypothetically we know we will creating the character, and for the example I am writing this character. In actually I am not creating the character. How could we play, how could we find it out? Like see, we calculate the length of it. As I told you, this is how we can calculate the final length of the result, right? Final length of the result. This is how we can calculate. So if we know the final length of the result, then I have only one property, that is nothing but my length. So I have to play with length, and somehow I can know like how to find out the k, how to find out the letter present at the k thing is in the final case. Now for this asterisk, how could I say? So k equals to 0, k equals to 0. So length could be, so length is here. See here, initially length equals to 0, then length becomes 1, then again length becomes 0. Correct. Then again length becomes 1, then 2, again becomes 1, then 2, then 3, then 2. If you notice from here, k equals to 0 means what? K equals to 0 means my length should be 1. So I have to find out the last appearance of k length equals to 1. So that means what? This length equals to 1. After that, you can see there are many cases when length equals to 1. See, Why I am checking length equals to 1? Because k equals to 0. So whenever k equals to something, I will check the length of that something plus 1. Because that's why indexing, how indexing works. Length minus 1 is index. So k equals to 0. So I need to find out the kth character. So I have to check when the first time that kth appear, that kth character is fixed. After that, it is not being changed. See here my k character is 0, so I have to say when my 0th indexed character is fixed. But if I start from the beginning, it is 0, then again 1 to 0, so again it becomes 1, then becomes 2. It could be like a star, a star, a star, like that, right? So that time it becomes a, then it becomes again nothing, it becomes a, again nothing, again a, then again nothing. This is how it will iterate, right? So from the beginning I cannot calculate. Correct. From the beginning, I cannot calculate. So that's why I'm iterating from right to left. Hope you are getting it. And another reason to traverse from right to left is I am hypothetically thinking this is my length is that, or my character is that. Now how I am getting back. So my target is whenever the main target, this for right now my target is for the asterisk case, my target is when my kth character is kind of fixed. Fixed means, that means I have to check when my L becomes 1, length becomes 1. So length becomes 1, the last time length becomes 1, I can think of last time when length becomes 1. So why I am checking for the last time? Because there are multiple cases when length becomes 1. So last time when L becomes 1 and it never ever change, becomes length becomes a 0 or less than 1. That means what? That means this is the for the last time it is getting updated. Okay, so that means for in after that onwards, this character is being fixed. Nobody is going to change that. So I will check. So what I will check in the case of asterisk, I will check whenever my k is becomes L plus 1. Sorry, length plus, not length plus 1, my bad. This is initializing is fine. Initializing is fine. Initializing fine. So what I have to check if L equals to k plus 1 or not. Okay. So this is the thing I have to check. Correct. So I have to check this way. I have to check this way. L equals to k plus 1 or not. So with the time L becomes k plus 1, that means that I got the point when this index is kind of fixed. It could be 0, it could be 1, it could be 2, anything. Okay, it could be anything. So right now I'm checking for 0th index. Okay, for that, that's why I'm backtracking. So backtracking means what? Now backtracking means what? See here, initially what is this asterisk means? What is this asterisk means? Asterisk means remove one character. So what we have currently right now, we have only length. We don't have any English characters or letters or result string, anything. We don't have anything. We only have the length. So whatever we have to think of length perspective. So asterisk means remove the length by 1. Now I have to do the reverse. I am doing the backtracking. Backtracking means I have to do the reverse thing. So that means in the reverse thing, asterisk means include the string. Add one character in my length. So that means I am relating the case. So here, if I get asterisk here, that means earlier I have more characters. Now I am removing. So I have to go back to the earlier character, number of characters. So that's why I am including the length. Okay. Then what this means? Surf. Like, okay, we'll talk about this whenever we will checking that thing. Okay. For this right now, it means like I will include the length. Okay. And another thing is, like it is for sure guaranteed our string only contains English alphabets letter, right? So whenever we get an English alphabet letter, we'll simply check this condition for this, as I am considering, like we consider our string only contains ABC, so like English alphabets, lowercase, and the asterisk symbol. Okay. For in this case, I have to check whenever my L becomes equals to K, I will stop. So whenever it will possible, it is possible when it is a character, my current index in the character. Why? See here, my result is nothing but containing the English lowercase, right? No star, no hash, no asterisk. Sorry, no, I'm saying star asterisk, no modulo. Okay. So in that means, what is my answer would be? It is nothing but the characters, lowercase characters present in my given string. That is my lower. That is will be my one of the answer. Correct. So So that's the reason. Whenever I got any character, I'll explicitly check this one, like whether it is a perfect or not. Okay, let's do the diagram, then we can understand. So currently my length is nothing but 2. So you can see at the end, my null length becomes 2. So I will start backtrack. So first criteria is asterisk. Asterisk means what? Whatever in my future I have more length, so I have deleted the length. So length becomes 3. So now this becomes E. So this becomes E, right? So E could be my answer, correct? E could be my answer because see it, E is a lowercase English character. Answer is all must be a lowercase English character. So this E could be my answer. I don't know. It could be my answer, could not be the answer. Can we check? So see what is the whenever I'm getting this E, so what is the that time the length is what? Length is that time 3. So whenever getting I'm getting 3, so sorry, whenever getting I'm E, so that time my length is 3. And what is I want to check? I want to check 0. I want to check 0. Like K is a 0. So that's why what length I want to looking for? K plus 1 length I am looking for. K plus 1 length I am looking for. That means 0 plus 1 is 1. Okay. So whenever I'm getting E, that means I am that time I am my length is 3. So that means this cannot be my case. This cannot be my case. Okay. So what I will do, I will move to the D. But before moving D, what is the star means? What, as I told you in the terms of length, star means remove the length. Remove or reduce the length. Reduce the length. All right. Reduce the length. Star means reduce the length. Correct. Opposite it was. I am doing opposite, increase the length. Correct. What is the English alphabet? A to Z. This means increase in terms of length, increase the length, because when I am getting any alphabets, I am simply add into the or result string. So that means I am increasing the length. Opposite will be decrease the length, decrease or reduce the length. So that means my E is not answer, but E is an English character, so I have to decrease the length. So it becomes 2. So I am staying. I was there in this firstly in this block. Then E was appearing this block. Now I am currently in this block. This block, correct? I am currently in this block. So in this block, it is nothing but my D. Okay. So that is nothing but my D. Cool. So if it is D, that means, so I will check whether is it my correct index. No, it is just not my correct index. Okay, it is not my correct index. So because what? Because my D is, when my D is appearing last time, D is appearing when index is 2. So it is appearing in the 2th index, but I am looking for fast index, 0 position. That means sorry, index is not index is 2, length is 2. Length is 2. I am looking for when my length is 1 because I am looking for 0th index. So I am checking when the last time my length becomes 1. That will be my case. Okay, so in that is not the case, so I will decrease it, it becomes 1. Now you can think, like, okay, length becomes 1, then I will return what is my index position. But think, whenever I am doing that, next index position is nothing but my asterisk. I cannot return asterisk because asterisk is not the case. Whenever I get any English alphabet, then only I can compare this logic whenever I got the English alphabets. Otherwise, I cannot check the logic. So even though my length become 1, that is my suitable length, I cannot change my length. Cannot change my length. Sorry, cannot return the character. Sorry, my bad. Cannot return my character. So it will stop. So after that, I got asterisk. Asterisk means what? Asterisk means what? I am removing one character. So in terms of length, I am adding. So length again becomes 2. Got it? Fine. Then let's see what is the uh, so this is after the removal of the this is the case. So asterisk means this case. It becomes removing. So before asterisk, what is the character? It is nothing but C. So this is the character I am checking whenever C is appearing. When C is appearing, what is the length of that? Length of that C is nothing but 2. Correct? Length of the string is nothing but 2. So what will happen? So now this C cannot be my character because C is appearing that moment when my length is it becomes 2. Okay, this is becomes 2. So C cannot be the case. C cannot be the case. So I will remove the C. Remove the C. I will move forward with the B. But going forward with that, I will remove the length because C is not being added. So before the C is being added, length is 1. Now see the case. This is the case when length is 1. Length is 1, and it my length is 1 and B is appearing. So I will not check the further details. I will not check the further details in the past. This is nothing but past or what happens before P. I will not check before the past. The moment I got, this is the first time one valid character. Valid character means English letter is appeared, and in the correct place I am looking for zeroth index. Zeroth index means length 1. Whenever I am getting the first valid character, that means this must be the character I am looking for. So I'll simply return like s of I. Either in the sense like let's say I is writing from this right to left. I'll simply return s of I. This is the character I am returning. Okay. Hope you get the problem. So this is for my case, my hypothetical scenarios when my character is only lowercase and asterisk. This is the time I will return it. So I will check when is the first time my length will be like k plus 1. When the first time the length will be k plus 1, and it should be a valid case. See here, length becomes 1 2 times here, but this is not a valid case. Why it is not a valid case? Because my pointer point to the asterisk. Asterisk cannot be my valid character. One valid character must be one lowercase letters, English letter, right? So that means whenever one valid character will appear and my length is also matching my condition, this length become k plus 1. In that case, I will simply return my current integer. For this is the case. Hope you get it. This is the condition for our lowercase and asterisk correct. Fine. Got it. I hope so. Now let's think about our modulo operator. Modulo operator. Okay. Let's think of our modulo operator. So modulo operator means what? Modulo operator doesn't contribute anything in terms of length. Correct. Because in terms of size it doesn't contribute. Because it is just reverse the character, reverse the string. Okay. So in this case, if my character is reverse or something, so in this case my target will be when I can get my target will be what is the final character. Let's take the example first, then we can talk about what to find. So this is our case. So A was added, it becomes A, then B added, it becomes AB, then C added, it becomes ABC. Then I am applying modulo operator here. So ABC becomes CDA, it just reversed. Okay. Then I got D. I got this, so CDAD. What is my K? K equals to 2. 2 is nothing but A. So this is my A. Correct? I want to find. So now my question arises like when this A, from which place this A is coming? How could I find this A? How could I find this A? So I have to check from where this A is coming. So A is actually C1. This A is present right in the second index, right? This A is present at the second index. But actually from which index it is coming? It is coming from this index when L becomes 1. It is coming from this index. So if it is not reversed, then it is coming in this place. Okay. So how could I find out this index place? So if I take an example, let's say A, B, C, D. Okay. So and it reverse will be D, B, sorry, not D, D, C, B, A. What is the index? 0, 1, 2, 3. And its index is 0, 1, 2, 3. Let's say here my K equals to 3. if my k equals to 3, if my k, what is the index? Index is a, what is the index value of the actual index? That is nothing but 0th index. Okay, what will be the value of k equals to 2? K equals to 2, index is like character is b. What is the actual character, actual position of that index is coming from? Actual position index coming from 1. Okay, now k becomes 3. It is nothing but why to not 3? It becomes 1. If it is 1, at index is like character is c. What is the actual position of the character? It is 2. And for k equals to 0, character is d. What is the actual position of the character? Is nothing but my 3. So this is how appearing. So if we discard these things, like let's say d is appended at the end. So if we discard this d, so this is a discarded part. Okay, this is a discard. I discard this part. Okay, so it's, if I discard this part. Okay, so then I can simply get this a. So this my current character is 2. Sorry, character is 2. So that is this a. Now I have to check where this a is coming. So this a is coming from after reversal. After reversal, this is my answer. So before reversal, what should be the place of this thing? So thing is, I am finding one to the place of this kth value. Okay, after this kth position, this is the final case. If I discard that d. Okay, so in that case, my index is pointing to this a, this position, this a. Now my question is like, this is obviously this is not the answer, because no, not a, because the answer, because see, what is the index present in this actual string is 0 1 2 3 4. So I want to got the answer at the point of kth index, second index. Now my answer should say like, from where this a actually coming from? Before reversal, where this a should come from? Before reversal, it should come from the 0th index. So how could I know this? This is the case. So that means, instead of searching in the k equals to 2, I should search k equals to 0. K equals to 0. Why I am going to search that? See here, what actually you are doing here. Here actually you are doing backtrack every time, right? Backtrack in the sense like, from before, like if I do modulo, then I am getting this character. So what I have to do? Reverse the modulo. Reverse the modulo means I have to get back the case. So whatever my k is pointing there, so what is my current second index, I have to look the case, like where actually this index is originated. This is actually coming from the 0th index. From how could I get that? How is there any formula there? For that's why I given you this example. If modulo appeared, like it is actual, this is the string. If the modulo, if I do the modulo, it becomes this string. So if k equals to 3, what is the actual index? 0th index. If it is becomes this index, what is the actual index of that? It becomes index number 1. Is there any kind of formula? If you notice, like, see what is the L here? L is nothing but 4. So if I do L minus k minus 1, 4 minus 3 minus 1 is 0. Then L minus k minus 1 is 1, because k equals to 2. This is how I can calculate. So instead of searching, like whatever I am searching here, k equals to 2, whatever present in this k equals to 2 value, it should be originated from k equals to 0. So now again we are going back to the same case, k equals to 0. Now I have to check whenever the first valid k equals to 0 is there. So earlier in the example as well, we are checking k equals to 0. Okay, kind of, I don't take k equals to 0 intentionally. It is happened coincidentally. It is become same case, but whatever thing is, earlier whenever k equals to 0, what actually checking, like we're not checking k equals to 0. Don't think of k equals to 0 thing. What actually you're looking for? We're looking for the valid character when it is time appear for the first time, when length become k plus 1. When the length become k plus 1 and kth character, k is a lowercase English character, that time I'm stopping. Here also same thing is happening. See here also what is happening, what actually looking for. See here, I am checking for k equals to 2. Now I know this k equals to 2 is coming from some L minus k minus 1 place. So k should not be k equals to 2. It should be updated by k minus L minus k, L minus length minus k minus 1, this place. So this place is nothing but my this place. Now I have to check when this place is like, when this in that place character is filled. So that means again I have to check whenever my length become k plus 1 and my kth place, like in that index my one valid English letter is present, I have to check on that only. Okay, I have to check only that. Correct? Fine. So what I will do, I'll check, I'll simply do this thing. If I get this character, if I get this character, I am simply do L minus K minus 1. Then do I have to change the, what should I say, do I have to change the length? See, modular doesn't contribute in terms of length. So we no need to change anything, correct? We no need to change anything. Okay, before that, let me give you one small example. In the example, in the sense, like what is the case of here? Let me write the part case. So if I remove this case, what is the pseudocode for asterisk before that? Okay, let me finish this one first, then I will go for the asterisk. So let's remove, take this thing, slightly reduce the, take some space. This is one example. So what is the case here? So if what I am doing here, if my character equals to, when I am doing backtracking from right to left, if my character equals to my modulo, what I am doing, I am simply doing k equals to k will be updated by length minus k minus 1. This is my update. Okay, got it? So okay, let's, okay, we will give a good example in the next below case, so that's why I taken the second example. So see here, if I do your our condition L equals to initially 4, I know it is 4, so it is starting from this index or not this index, this index. So then D is appeared, so my k equals to 2 and my D, so my primary target is again I have to check for the length of k, length equals to k plus 1, I have to check length equals to k plus 1, in which at that time, if it is the case and it's a valid character, I will return. Again, I can notice. So when D appeared, the length was 4, so it cannot be the valid character because I am checking L equals to k plus 1 case. So D, I have to go to the before what D appears. So before D, what is there? It is this case, C D A. So I will simply reduce the length. Length becomes 3 because I am not adding D. I am considering D is not a valid. So removing that D. Before adding D, what will be the length? Length will be the 3. Now K is 2. K is true. So but my character is, when I can check this condition, as I told you again, I can check only this condition when my current character is English lowercase character and this condition is 2. But currently I am checking my L becomes 3, that is, and my K equals to 2, so it's a valid case. But the current character is nothing but my modulo. So I cannot check, it's not English valid case, so I will not. So modulo will do what? Modulo will upgrade whatever this K current now should be this character. This should come from this index, not currently K equals to 2 the index. So it should come from that index. So K will be updated. K earlier was 2, now it becomes 3 minus 3, 3 length is 3 right now, 3 minus 2 minus 1, nothing but 0. So K becomes 0. So now K will be updated. So K will be, length will be changed? No, length will not be changed. Okay, next character becomes C. Next character becomes C. Correct? If it is C, so that time what is the case? My right now my K value is updated. K becomes 0 right now. So bad luck, K becomes 0. So I have to choose the length equals to 1. So that time K equals to C. C is not the case. So I simply remove the C and it becomes 2. So it will not the case. Next I am come to the second place B. B, whenever B is appearing, that time length is 2. So I am looking for length equals to 1 as K equals to 0. So I have to remove B and length equals to 1. Next character becomes A. It's a valid English case letter. English lowercase letter, sorry. English case letter, what I am saying. English lowercase letter. So in that time, my K is like length is 1. That is nothing but K plus 1 and it's a valid English case letter. So I simply return S of I. Okay. Simple. Simple as that. So if this is the case, then I will write this condition. Otherwise, I will return. I will check what else. Else. Else means what? I'm considering my character only consider a percent symbol and percent symbol and it's not modulo symbol and lowercase case. If that is not the case, else means what? It is should be an English lowercase letter. In that case, if it is English lowercase letter, I will consider check whether if L equals to k plus 1. If that is the case, I'll simply return current case, return my s of I. Okay. Otherwise, if that is not the case, if it is not the case, else what we'll do, I have to change the length. So length will be, it will be decremented by 1. So length minus equals to 1. Okay. Simple case. So this is for the modulo symbol. Let's take a good example, and this is this example. Okay, let me pause the video and rearrange these examples so that it will be easy to explain. Okay, I have rearranged the letter use cases. So let's see what is this case for this example. So my k equals to 1. K equals to 1. Should I take k equals to 1 or should I take k equals some more values? Final values 3, right? Another. Okay, instead of k equals to 1, let's say k equals to 2. Okay, so k in the case of k equals to 2, what will happen? Say, let's do this same way. So my A equals to currently, right now it is 5, length is 5. So first when I try to right to left of my character, I'm trying to backtrack. So first right is E. So E, my target is what? L equals to k plus 1. Whenever my character is lowercase letter, I'll do that. So L equals to 5. E is nothing but E is length is 5 and k is 2 plus 1 is 3, so it is not equal. So I'll move forward. So length change to the 4, length change to the 4, and this is modulo. Modulo means what? As I told you, modulo, whenever I'm getting modulo, so modulo will do change the k, because we have to find it out from where this k is originated. This k is right now nothing. See here, if I am this is done before e, this is the case. So I was looking for 2 plus 1, k equals to 2. So this is how, this is the place I want to find it out. Now I have to check where this is, from where this b is coming. To check it is coming, I have to do this thing. It is coming actually length minus k minus 1. So that is now k earlier, k was initially 2. K was initially 2. Now it will be updated by right now length is 4. 4 minus 1 minus 2. It is nothing but what? So k will become 1. So right now k will become 1. Okay, fine. For this modulo, do we have to change any length? No, it will not have any effect on length, so it will move forward. Now next character will become my d. So in the d, it is a lowercase letter, but I am looking for right now length equals to 2, because k equals to 1 right now. K equals to 1, so length is 4 right now. So it will not any take place. So it will remove that case, this case, and it becomes 3. Fine. Now pointer move to the modulo. So modulo is right now here. So before modulo, so before adding d, so if I remove the d, so this is a d case after adding this. So before adding this is the case. I am looking for which place? K equals to 1. K equals to 1. I am looking for this place. Fine. Okay. So again now I am now getting this modulo symbol. Modulo symbol means again k will going to update it. So k will become, so right now length is 3. 3 minus 1 minus 1. This is nothing but 1. Simple. It will be updated by only 1 by 1. So so if that is the case, so okay, let me give you another case. Let's add one a, so it will be much more interesting. Or leave it, it will be same thing. So same way, like if you add another a here, then it will be just add another a, everything will be added. One a will be added every place. So that time string will be slightly differ, but at the end result is obviously same. Okay, that's why I'm not adding. So right now k equals to, I want to find k equals to 1. So I got modulo not have any effect on length, so I will move forward. Next pointer is nothing but my C. C is what? C is an English case letter. So it is a valid case. What is my length? Length is 3. What is I'm looking for? K equals to 1. That means length equals to 2. If length equals to 2, my answer actually not should be the A. Answer would be my B. As I changing K equals to 2, answer will become, this is my answer. This B will be my answer. Okay. So as L is at the third index, L equals to C is currently my index. Like my pointer is currently pointed in the C character, and length is what? Length is right now 3, but I'm checking for K equals to 1. That means length of 2. So it will not do any problem. So it will, for C it will reduce, because if it is fine, if its length equals to K plus 1, I simply return SI current pointer character. Otherwise, I'll reduce the length. Length becomes 2. Next pointer it becomes B. B is a lowercase letter, so it could be answer. So I'll check. Length is 2. It is matching. It is nothing but K plus 1. It is matching. So B is the case. So I'll return S of I. Simply I'll return S of I. So B is the answer. This is how I can get it from this. Whenever my English character comparing getting this modulo and this kind of and lowercase letters, and when my string is lowercase letter and modulo, then I can use this approach. Okay, for approach of this asterisk. So if my character is nothing is equals to asterisk, that is the case, then we can simply, what I was doing, I have to reducing the length, right? It will not update the value of the K. It will simply reduce the length. Length minus equals to what? If that is not the case, then it is the else part. Else part is nothing but is a character. So simply same thing I was doing whenever I was checking there. Copy and paste. Same thing I was checking in this case. Okay. Now see what will happen in the case of hash. Hash is doubles the case. So in the terms of length, here hash has the kind of contribution on the length, that is doubling the length. So when I am doing the reverse of the hash, that means I have to half the length. I have to half the length. Got it? Okay, fine then. Let's see then how we can solve the case, this hash case. So in this example, I have added A, then added B, B is here, then hash is applied. Hash is double the case. Then I have added C, A, B, A, B, C. Then hash again double the case, A, B, A, B, A, B, C. So let's see what actually doing. If I do the reverse, like now, if I check K equals to 6 here, K equals to 6 means in this case it is B. How could I find it out? Okay. If I remove the hash, last character is hash here. If I remove the hash, this B is coming from which place? If you notice, this B is coming from which place? This B is coming from nothing but this B, same B, isn't it? If I did 7, this 7 is coming from which place? This 7 is coming from this place, correct? This 8 is coming from which place? This 8 is coming from this way. So if you think this way, if my character is part, this is the half of it, this is the half, this is the half, because this is my origin, like my first string, and for on which string I apply the hash. So this is the first, this is the second part. So if my K is present in the second part, if my K is present in the second part, then I can simply half the length and I can repoint the K again to this current pointer, like how I was doing in the modulo symbol, like I was repointing the case. So that's why I'm repointing the case. Think again, it is a thing. These strings are just for imagination. I'm not using any string. See, in the first two pseudocode, I never used my string array. This character is part of my string, given string. Then everything I am doing using the length only. These characters are nothing but what I given the example is just for your imagination. Easy to understand. Here also I didn't use any result array, right? Result string. Okay. Just similarly for this one as well. This is also your imagination. This is not actually thing. So technically, you can think like if my k is lies between like half of this length, like what is the length this 10, so it is equal, it is greater or equals to this length if k so if k is what, if k is greater or equals to length by 2, so that means it is part in the second part, second half. Second half means what? Second half means this any character of this second half is any character of this second part. Any character of this second part. Let me just a minute. Yeah. Second part have is one copy of it, isn't it? Has is nothing but copying the one character. So any character in the second part has its own copy of it. So instead of finding that place index, I can say like find the index actually for which it is the copy. Which copy is this? I have to point to the data index. So how could I find that index? How could I find that index? Let's take a good example. So I have to find out again, reduce the formula. So A, B, C. Let's say this is the case. So our index, if I do the copy of it, it becomes okay. Let me do only A, B, C. Let's say A, B, C, D, E. This is my original index. If I apply hash, it becomes again A, B, C, D, and E. A, B, C, D, and E. So what will be the index position? Index position is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the actual point, like index position of this E? E is nothing but this 9 coming from 4. Like okay, for 8, for this D is coming from this D. This 8 coming from 3. This C 7 is coming from 2. This 6 coming from 1. And 5 is coming from 0. Okay. So from this case, what is the formula I can deduce? I can deduce k equals to, what is the formula? K minus L by 2 length by 2. If you use this formula, see, length by 2, length is nothing but 10. Length is 10 here, is equals to 10. So 10 nothing but 10 by 2 is 5. 10 by 2 is 5. 10 by 2 is 5. So 5. So if I current k is what? Current k, let's say the current k is this 9. So if I remove 9 minus 5, it becomes 4. So what you notice, like this is my current k value. This is my current k value. From this current k value, if I remove, like reduce the half of the length. So length is 10 by 2. 10 by 2 is 5. So 9 minus 5 is 4. 5 minus 5 is 3. 7 minus 5 is 2. This is how. So this is how we can calculate. So whenever we get hash, okay, that time we will simply update the length as well as the what should I say, as well as the k position as well. So for my asterisk, if you notice my asterisk case, in the asterisk I update only length. I didn't touch k. Okay, kth position. For modulo, I changed k but didn't touch my length. But this case, this is a special case. This has not only increasing the size of the string, it also have keep a duplicate copy. So I have it's a redundant thing. So I can remove the redundancy and point to the actual object position. So this time I have to do the both. I have to check it, like if it is I have to update the k value as well as the length value. Length value I have to update is half, because applying hash it becomes 10. Before applying hash the length is 5, isn't it? So this is how we have to do. Final, clear, got it? So right now I am finding the 10, 6. Okay. So length is, let's do the dry run. Length is 6. Sorry, length is 10 right now. So as usual, I will try to find the case when my length equals to k plus 1, and for which case? For the case when my current index is a valid case, valid English lowercase letter. Okay. So currently my point is hash. So whenever I will get hash, I told you what I will check whether k is greater than my greater equals to length by 2. If that is the case, I will simply update the k value. Okay. So what will be the then formula of that? Okay, formula, if I write it down, what I will do if I get if I get character equals to hash. So if my character equals to hash, I have to check multiple things, couple of things. First, I have to check if my k is greater than or equals to my current length by 2 or not. If that is the case, then I have to, it's a redundant case, I have to reassign it. Reassign it by, wow, like k will be k minus length by 2. And if it is not the case, else if it is inside the case, that means what? If it belong to the first of it means it is already it could be in redundant case based on the case, but right now based on this is not this string is not part of a redundant case. This is a part of a original string. This is because before has, this is the original string. This is part of original string. I will not update the case. But one thing I have to do, even if I get L length, I have to do the half length by 2. This I have to do every time if I get it. Okay, simple this thing. Let's dry run it. So length equals to 10. Current character I get hash. So hash, my k is 6. K equals to 6 as well. K equals to 6. That means this 6 character is redundant, isn't it? This 6 is present what? Length is 10. It is time greater or equals to 5. 6 is greater or equals to 5. That means it belongs to the redundant. So instead of finding the redundant, I have to check from where this b is coming from. This is coming from, right now the formula I will use, k will be 6 minus 5. This is coming from 1. So k becomes 1. K becomes 1. Fine. So after that, I have to update the length also 5. So right now I am checking for k equals to 1. That means length equals to 2 I am checking. So right now my length, what next character is? Next character is C. So C is a valid lowercase letter. So I will check the length. Length is not k plus 1, nothing is not 2. So I will update. So in that case, if it is not the case, then I will update by 4. So same thing applies here as well. Like if it is a lowercase letter, I will simply say the same logic. I will give the same logic. If it is a lowercase, then logic is same. Okay, hope you are getting it. This is very nice and problem. You have to dry run, or have to take some example, dry run it, then only you can clearly understand the problem statement. This is a nice example of string. Okay, so currently I am at the C position. C is not good enough, so I am reducing the C place, and then I will go to the next place, that is hash. Hash is now 4. Okay, so 4 has got, and length is 4. So is my current k is value is 1. I am looking for k equals to 1, first index. So is it my greater than my 4 by 2 2? No, it is in the correct place. It is in the correct place, right? If it is in the correct place, that means what? That means I'll just only update the length. Length becomes 2. Okay, fine. Now next becomes B. So this B, what will happen here? B here it will be the same. B here it will be the length is 2, k plus 1 is matching, k equals to 1, length equals to k plus 2, so B is my answer. So this is the first time the k plus appearing, and or you can say like from where this is pointing to, like this, We are actually looking for k equals to 6 in this place, but the thing is this is a copy of this place, copy of this place, copy of this place. Okay, if it is a copy of this place, that means what? That means I have to check whether what I have to origin of this place. Now I can say this B is actually originated by itself. It is appearing for itself. So this will be my answer. So I return that S of I. B will be the answer. Simple that. So this is the case. So you can check this example. This example. This is also one example. You can take it. It will be same. K equals to 2. For that you can check it. I'm skipping this thing because of this time is already, I guess, exceeding 1 hour. So that's why. So let me give you one full-fledged example. This is a full-fledged of example you are looking for. My character is containing everything. So, has, star, everything it is containing. Okay. So let me go through once. What will be the my k equals to 4? K equals to 4 is nothing but B. So B will be my answer. Okay. So let's see where can I get B. So this B is the answer. Okay. So first if I go through it, just a minute. Okay. So if I go through it, first I add A, adding A, then adding B, then modulo, that means reverse. Modulo, that means reverse. Then I am adding C, C, B, A, C. Then I am using hash. Hash means this is the hash. Double of it. So then I am getting this one for then I am using asterisk, so one C will be deleted, C is deleted from here, then again asterisk means A will be deleted, A is deleted from here, then adding D is adding, then again modulo means this one, this again reverses D, B, C, A, B. This is my final character and my k equals to 4, k equals to 4. Let's see where from this is coming from. Okay, so right now what I told you, this all cases I will apply, the same condition I will apply. So first I will apply this one, or if it is a case, same thing, no extra changes. So apply this thing, it will work. So for you, let me give a dry run. This is the case for here. This is the case of the modulo. Copy. This is the case of the modulo. Copy paste. And this is the case of my hash. Copy. It will be pasted here. So one thing I have to write it here. So that is nothing but if character is that, else if I write simple else here, else if this is a part of else if and this is part of else. This character, this is part of else. Okay, and I was doing writing every time I'm doing from right to left. I am writing right. So for that I am writing this case in a for loop. Let's say reduce a little bit. Okay, I guess it is visible. For starting from my, let's say I starting for length of my string given -1. I don't write like this way to write the length. It is lagging. Why it is lagging? Okay, so it is s dot length -1. Still it will go I greater equals to 0, I minus from right to left I'm iterating. For character is nothing but this character is nothing but my string of I. I'm doing that. Okay, so as simple as that. So this is what I'm doing. Okay, let's start or do the dry run. Okay, let's put our example, bring our example here in the middle of the screen. Copy. and paste. Okay, fine. See, right now I know what is my length. My length is nothing but initially length is 5. Right, from here I can calculate the length. Okay, then my k is 4. Let's start iterating. Right side module, when I told you module, when I receive module, what I'll do, I'll rearrange the k. So k will becomes like, what is the right now, 4 minus 4 minus 1, it will directly gives me 0. Oh, it should not be 0 because it will, or what should I take? Okay, instead of k equals to 4, because 0 is not, I don't like 0. Let's take k equals to 3. Let's say k equals to 3. 3. That means 5 minus 3 minus 1, nothing but 1. Okay, so k becomes 1. So for modulo, we will only update the k, nothing else. So next I'll get English character D. So English character, whenever English character there, I will simply check this condition, AL equals to k plus 1 or not. This condition I will simply check. I'll check simply this condition. If it is true, then fine. What is current value of k is 1. What is the length is there? Length is 5. So it is not, what should I look for? Length equals to 2. K plus 1 is 2. Length equals to 2. I am looking for length of 2. But this is 5. So I will simply update it by reduce the length. Then I get numerator asterisk. Asterisk whenever I am getting, okay, I did a mistake here. It should be asterisk means increase the length. Increase the length. I did mistake here. Asterisk means increase the length. There it is fine. Here it is mistake the length. Asterisk means increase the length. Not minus equals to plus equals to. Asterisk means increase the length. Okay. So increase the length. Okay. So what will be the increase? It will becomes 5 again. Because see here, if you see the example, my earlier stage, this is my final output, right? Final output. First I get modulo. Modulo means this k, whatever I'm looking for, k equals to 3. This 3 is should come actually, but before modulo, this is my actual string. So this 3 actually coming from this one index. So that's why I change the index. Okay, this is the before the modulo. So I'm looking for this one index right now. Index like k equals to 1 index. Now I'm getting D. D is not the correct place because D is adding in the 4th index, and I am looking for first index, so it is not the case. So this is the, that's why I reduce the length. Length becomes 4 before applying the length equals 4. Now I am applying asterisk before. This is the string before after applying the asterisk. Now I have to check before applying the asterisk. Before applying the asterisk, length is 5. So for asterisk application, like I will simply increase the length. So I have increased the length becomes 5. So again I am getting another asterisk. Another asterisk means it will just increase the length. Length becomes 6. So it becomes 6. Okay, it becomes 6. Next is hash. Hash is what? Hash not only create a copy of it, but also it is kind of updating, like updating the, what should I say? Um, Updating the length twice. Okay, so what is the length of this hash? Current length is 6 and k equals to 1. So whenever I get hash and k is greater than length by 2, k is right now 1. It is greater than or equals to my length by 2? No, because length by 2 is nothing but 6, so it is not greater than. So this is the string before after applying hash. So I will simply reduce the string by 2. So string becomes 3. Next becomes I get C. C, I am looking for still k equals to 1. That means 2 length index. Sorry, 2 length of 2. String length of 2. So it is right now length is 3. So it will not create any problem. So it will do 2. So right now it will become 2 and it will now length becomes 2. But even though length becomes 2, I need one valid lowercase letter. But it is not a valid lowercase letter. It's a ampersand. Sorry, not ampersand. Modulo. So modulo means what? For modulo, I will simply reassign the k. So right now my L is 2, length is 2, and k is 1 minus 1. So key will become 0. Key will become 0. So next case it becomes B. B is the key is 0, so I'll need the length of 1. So it will not create a problem. It will not actually the case. So for it will update by 1. The next case I return as the A. A is the actual case. See here, A is the length of 1 and it is also a lowercase letter. It's a valid character. I'll simply return it. So that's how it should work. This is the whole cases. You have to think of each and every cases for special characters and backtrack it. This is how we can solve the problem. So if I write the problem all together, it is a very long code. So I'm putting it here. Okay. And also I need this part. First thing I've done. First thing. Copy. Paste. So this is the thing. First you have to come from here to here. Then you have to start here to here. Okay. Like after this line, directly come from this line. Fine. Hope you get it. So let's say function, give a function name. Function, let's say find k, find kth character, and given a string is given s. That's all. This s is given, and this is our end of the string. So what will be the time complexity? If you notice, I'm iterating each and every character is big of n. It is also big of n, iterating each and every character big of n. So after that, everything inside that is a big of 1%. It's simple if else if else if else. The time complexity is big of n. And space complexity, are we taking any extra space? No, we're just taking one length variable just to store the length. So that is why length is big of 1. Space complexity is big of 1. Okay. I know it's a hard problem and very long, so like very you have to think too much on this problem, but it's a very good problem. So hope you understand the problem. Thank you. As always, if you find any mistake in this video, please let me know so that I rectify. And if you find any useful information on this topic, please also let me know so that I can learn. Thank you. Bye bye.